Oh my. Oh my. Oh my, oh my, oh my. Here I am. Okay, let me post the link in the other channel. Here we go. Copy. You all think this is like, looks so, I make it look so easy, but then in our game development 1 class, you'd be surprised suddenly everyone has to do like a 5-10 minute presentation and like getting their screens shared and all this kind of stuff. And that goes to hell in a handbasket. So I try to make it look easy. Am I hearing you? Could someone give me a shout out just so I can? Oh, okay. I heard something. That was good. That was good. Whoo-wee. All right. So intro to game programming. Yes, that's us. We're here today. We're back. We're live. And we're going to talk about apple tree stuff and a bunch of other things. Who knows? Maybe a bunch of stuff that you're interested in actually working on doing and so on. In the meantime, among other things, I did post a bunch of links to a variety of the materials that we've been covering. Mostly direct links to the Google Slides. So that is available for you all to get at on the LMS. So you can find out things there. Check in on LMS. If you're subscribed to my YouTube channel, you probably just saw a deluge of all sorts of other videos that are computer graphics class videos and are not intro to game programming videos. So be careful if you suddenly start watching a video and it's like everything is totally in another language, literally, not a human language, but another programming language. Do not fear. Don't worry about it. You've just stumbled into the Twilight Zone. Don't worry about it. No, the piano things are just, they're just for fun. It's my YouTube channel. I'm just using it for class. It's not so much it's like a class channel. If you go through my channel, you'll find all sorts of different, my variety of different things, everything from my music programming to my Legos, to my robots, to my shop, to my whatever. So I'm just using the advantage of having a reasonably full featured YouTube channel so that I can do live videos, because normally you can't do live videos until you have a certain level of YouTube channel. So I'm doing that anyway. So yeah, the music stuff is just me having fun. There is a cool well, here's segues for kids. There's an RPI Audio Makers Club. I've been involved in a couple of different organizations and things, and certainly doing music is part of game programming as well. Eventually, you want to have music in your games. So if you have specific interests in music, sound, and so on, above and beyond computer graphics and games and all that sort of stuff, let me know, because there's opportunities for that sort of stuff in all kinds of areas as well. So that's a segue of sorts, I suppose. Let me make sure. Oh, I better start recording. All right. Good thing I didn't talk about anything really important yet, because I just hit record. But it's also on YouTube and recorded, so I guess that's all right as well. So many different things, so many different windows and buttons and all that kind of stuff to press. No, actually, I didn't want. I'm going to put that one over there and keep this window over here. Last we talked, we did a bunch of stuff with collisions and with our apple picker game and our apple dropping and all that sort of fun stuff. And one of the things I wanted to look up before and caught me without my my reference in front of me. Ooh, what happened here? Is that I wanted to check on the due date for our project. That seems like a good thing to know. And let me look up here and make sure it's on LMS so that we all know when the apple picker is really due. And let me switch to my other screen here. Here we go. So here we are. over here on LMS, go to Content, Syllabi, and Schedule. And we'll go to the official live version here. The apple picker is due any minute now. Well, not quite any minute now. It is due the 20th. And we are slightly out of phase with regards to some of the topics, which is okay, because you'll notice at the end I have these studio class topics and certain things that are listed up in here. For example, animation, delta time, fixed updates don't really apply to the apple picker anyway. Oh, actually, wait. So we're only supposed to be in here? Oh, we're fine. We're doing great. We're doing fantastic. But we're going to cover a couple of different things in here, and we're going to be great. All right. So it is due Tuesday, October 20th. And so if I were to look up a calendar and say, here's 2020. Oh, come on. So right now we are wait, where are we? Here, the 9th, which means we have the better part of, well, a week and a half or so. Here's the 20th down here. So it'll probably actually be the 21st. So, but one of these 2 days, if it's midnight or one day or the next, we're going to be closing in on it. So don't get complacent. It's going to sneak up on you real quick, and there you'll be. And you don't want to be like just surprised by it all. So it will happen sooner than you believe. All right. So that's the schedule on that. Hopefully 95% of you have noticed that there were grades. Hopefully grades got put up. Did anyone actually see their grades for the project? There were a few that still there's some issues with their not submissions so much. Well, it's the submission. It's not, some of them I've discussed the project, and we're just going to kind of iron out a couple of things. So a bit of a, it's out of 15 points. So there was lots of, people very close to 15 points. A lot of people had 15 points. There were, if I had to say one thing on the last one that people, and it might have caught a few people by surprise, and I have mixed feelings, but one of the main things that I looked for was the use of distance, like the notion that when things collide, we have to, think about vectors and think about their relationships, as opposed to having just a fixed grid that you're either at exactly a location. That means, okay, I got to this location and I triggered this action versus I'm at this location. If you're always just comparing an XY location to be exactly on something versus trying to dynamically understand the relationship between things, that was one thing where I tended to take a point off for that. Nobody lost a lot of points on projects, but I really kind of wanted to see that, because it's sort of the fundamental foundation for a lot of things in physics and relationship between objects on the screen, and how we're going to eventually you're figuring things like, okay, are we facing an object? Are we facing away from another object? Does the object see us? Can it see through walls? And so on and so on. So I wanted to kind of, prod you to make sure that you're thinking about the relationship between things in that way. But I think, the good news is everybody's, in a really good position. I think, I think we've got a really good group here. And I'm super, super optimistic about the rest of the semester as well. I think we're going to do great. So if you got 14 out of 15, don't sweat it. It's going to be great. You're going to be fine. So it's all good. Yes. Just let me know. Just let me know. I mean, at this point, basically what I would say, that's sort of, I would recommend that if you had like a really particularly big issue, if it's a difference of, in the end, when I do the final grades, if I see, the difference between a 14 and a 15, especially if you've been consistently really good on things in general, that's not going to, I will do some mental rounding in terms of discretionary. Notice there is a chunk of the grades that is discretionary and so on. So really worrying about going back and redoing stuff as if you just like really didn't get the concept at all. But if you want to, you certainly can. If you want to ask me about anything that I mentioned, just go ahead and do it. I mean, you still have the project there. And if it was something that you had a question about, why I had an issue and want me to take a look at it, great. Do that at any time. Give me a shout out, give me a direct message saying, hey, could you take a look at this? Or if you do have a question about anything and want to say, well, why would you recommend doing this or not doing that or something, at any time is good. Yes. So anytime is good. Does that have I wound up? Okay. In case you hadn't heard. So yeah, that was the question for repeating for the stream, just in case the voice didn't get in. The other one is really about revisiting older projects, in case you haven't guessed. So I'll repeat myself just a tad there. Okay. So here we are. I was trying to run, let's see, did I manage to get I didn't open up Unity yet, did I? I didn't open my Unity project. I certainly need to do that. So let's see here. I should have a 3 default. There we go. I think that's the one. We'll open up that one. We're going to open up actually 2 different things. The new version of the project that I'm just kind of creating on the fly with our Snow Kid and Soldier Drop and whatever it's called. And we'll also look at the simple tree. Now, one of the sets of materials that I put up in the notes that I point to actually has sort of a skeleton. And I don't mean the skeleton like ooh, Halloween skeleton. I mean the framework for one particular kind of approach to the apple picker, so some kind of suggested, what objects would I use? What kind of structure, how would I organize things in my code and my scripts and so on. Feel free to go ahead and, kind of use that as a jumping off point if you haven't or you're thinking about it. I forget that, I think was at least 3 semesters, maybe 2-3 semesters ago now. So now I'm always kind of reinventing the way I'm working on things depending on new features in Unity and so on. But old stuff continues to be valid, so can't complain. So let's see. This looks awfully empty. Why does this look so empty? This is not what I meant to open. It's a game dev one, not intro to game programming one. So much for my chewing gum and walking at the same time. All right, let's open up this one instead. So try that again. Open up Unity again. Close that one again. And so last time we discussed basic input, which was the use of the mouse, the keyboard, buttons, and keys, and general mouse movement. We kind of went about it the kind of most straightforward built-in way without getting too much into the input axes and the programmable input system that Unity has, the various versions of the programmable input system, and really kind of kept it to the kind of basic built-in event-based and some of the underlying simple basic input pieces. And we expect to use that for the first, or for this next project, in terms of how you're going to move the baskets, the player in your game, and move things around and so on. So that's how we're going to deal with that. It's taking forever to load. So today, one of the things that we're going to talk about, and I'll go to this while we're doing that. Why not? And we've used scene management already quite a bit, actually. We kind of now, especially starting this next one, ideally what should happen in the game, you should make sure that all of your scenes are included as part of your project. And when I hit play, what should happen is I should be presented with the main menu of your game, which will say Adventure, Apple Tree. There could be this order, but they may have different names. It could be, Adventure Quest, Mad Bomber, Enter the Curmudgeon, and Super Meat Boy, whatever. But in that order: Project 1, Project 2, Project 3, Project 4. And I'm going to click on one, and it's going to go into that scene. So we have dealt with scene management to some degree already, which has been good. The basics of loading scenes, kind of exit one scene, you start the next scene. So we'll talk a little bit about that, but also talk specifically about player preferences. So this is a relatively short presentation. I'm going to do kind of hopefully a 2-for-1 kind of deal presentation-wise today. So talk a little about Project 2 again, just as a reminder. This is yet another version. Now, Project 2, the idea is that you do have this apple guy, for one reason, this nasty crook throwing apples to try to escape from wherever. And you'll notice there are certain lives, and you have a certain score. One of the things we also want to have is a high score, right? So the high score, you're going to keep the high score. It's going to persist as you go from game to game. So if I play tomorrow, I can compare that against the score that I had today, right? And once again, the basic rules here and so on. Use an array of baskets, or perhaps a list of baskets if you really want. You're going to use a list of apples or other things so that you can get rid of the midair apples. The general thing is that we have 3 baskets that move with the player, right? This is not a up here. You could, if you want to have number of lives left up here, that's fine additionally, but we want to have 1, 2, 3. The baskets moving with the player down here as well, unless you come up with some really compelling reason not to have that. But instantiating baskets and keeping them in array generally is the practice. But so you can have an additional lives indicator if you like up there, but we want to have stacked baskets kind of going on in there. Catching items increases the score. If you miss an item, you lose a basket or life. And maybe there's other things that cause you to lose life in addition to missing an item. Maybe you catch the wrong item. Maybe you go off the side of the screen. I don't know, things like that. Be creative. The more we get towards the final projects, the more creative we want to be along the way. And here, specifically using player preference to save and load the high score, right? So let's review scene management real quick. We use scene management for stages, levels, configurations, splash, and end screens. And for the most part, you've seen the basics of that already. There's actually another feature that we've never really required in this class, but it's something to be aware of. One of the things that's interesting about scenes that you probably wouldn't even guess if I just went through here, but since you're all so advanced on things, we'll talk about as we get to the bottom of the scene. So a scene is generally a unique level or portion of a level in your game that contains the game's environment, its objects, its menus, and so on. Notice I added that part about a portion of a level, perhaps. When you're creating scenes in your Unity interface, this is talking about saving them from the Unity editor. You go to File, Save Scene, or press Control-S. Right? Scenes are saved in your Assets folder along with everything else. Right? So they're there. Now you can open a scene by double-clicking on it. Scene asset, File, Open Scene, and so on. You can create a new scene, File, New Scene. This is all just the general stuff inside the Unity interface. Working with scenes from script. Normally, this is the basic parts, right? When we want to load a scene, when we want to use scene management, we have to make sure that we say using Unity engine.scene management so that it knows about us using it. And then we use generally one of these functions, load scene by giving it a name, load scene, giving it an index, or load scene, giving it some sort of, again, sort of an index. Now, before I leave there are ways, and I'll let you know about this without getting too much into the details of it. I'll leave it for those of you who want to get more advanced. And once you get the other stuff done, if you want to be fancier, you can do this. You don't have to unload a scene before loading another scene. Now, what do I mean by that? That means you can basically have sort of sub-scenes. So imagine you are in a room and a door opens and you walk through the door into another room, you can actually make the second room another scene and load it while the current room that you're already in is already loaded, right? So scenes, it isn't a one per game deal or one at a time deal necessarily, right? So you can do things like even create scene relationships that aren't just about, okay, here's what I see on the screen. A scene could even be something as interesting as, you could do something kind of wacky, like a collection of prefabs that are sort of a subcomponent of the scene that you're currently on, or some room within the scene, or some complex object could actually be a scene that gets loaded into the current scene. Right. So there are even more complex ways. I mentioned this because one of the reasons, because it's cool and it's very useful. And we actually, in Game Dev 1, we work in Godot in addition to Unity and Unreal. And in there, Godot has a very interesting architecture in that its idea of prefabs are really, it uses the concept of a scene to be more like a prefab. But now in thinking about it, you can sort of even extend Unity in a similar way by using scenes as subscenes and then loading scenes into scenes and so on and so on. So it's a more of an advanced topic. For now, though, we're going to be typically loading a scene, and what load scene does, if you're not doing it asynchronously or you're not doing it additively, it just basically loads the new one and drops the current scene off the face of the earth or out of the machine, goes away. And the new scene starts from scratch, and there's no relationship between the two almost all the time. With these other features, you can potentially break that and do other cool stuff, but you're definitely not going to need that for the apple picker. The apple picker is a single scene, other than start scene, play a game, and then if it runs out of baskets, go back to the beginning scene, sort of thing. All right. Now, there is the flip side of that coin, or another issue there. There's this other idea, like, well, what if, for example, you load the scene, and you may have noticed this in my Simple Tree game, where the loading scene starts and music is playing, and I hit play, and it goes into the actual game scene, but the music keeps on playing, right? The music doesn't stop and get reloaded and play, from the beginning again, or play different music in the scene that gets subsequently loaded. Okay, so that's a bit of a different thing, because there's an additional feature called DontDestroyOnLoad, which you can pass any game object to DontDestroyOnLoad. And what that does is it basically pushes it a little bit out of the scene. I mean, it's still in the scene, but it adds it to a specific sort of collection of objects that will not be destroyed when the current scene is destroyed, and will then travel to the new scene, right? So it's not about adding a new scene to the current scene. It's about taking a specific object in this scene and having it live on into other scenes that you load, right? So this DontDestroyOnLoad allows you to do that. Preserve some object, and it might be maybe the player in the game. In addition to just being kind of music, it could be something more complex, like a player or an enemy, or your object that you're keeping track of certain data with, and so on. Right? We're not going to use this for our high score, but that's another thing. All right, so this is a common pattern. So in programming in general, and in game programming specifically, we start to refer to these things called patterns, which are sort of best practices or techniques that get used over and over and over again. And this notion of certain kind of techniques as patterns is something you'll hear about in various courses you'll be taking. All right, so the common pattern for this sort of thing is creating a splash or loading scene before your start scene. You might put persistent objects in there so you can then reload the start scene without causing any issues. Otherwise, you might need the use of singletons, and a singleton is a sort of pattern as well that allows you to basically make sure you only have one of something loaded at a particular time. For example, if you had already started the background music playing and you start a new scene, you don't want more background music playing if it's the same exact background music object, for example, right? Or if you had the player already loaded and then you load the scene again, you don't want to create a new version of the player. You want to prevent that. And that's what singletons are about. When you have some sort of object that you want to make sure there is only one of, there's only one player, maybe. So, normally we would do an exercise here. We would say, we'd stand up out of our chairs and we'd flex a bit. And then, once we had a good stretch going on, we would work with some scenes. But you've already done that. So I'm not going to stop and say here, but it is a good opportunity to do this and put this into practice. This is, use the sample game asset package that I send out if you need to. I'll repost that again if you haven't already grabbed that one. So go ahead, write a script to navigate from one scene to another when certain input happens. If you press a button, the user presses a key, and so on and so on. Right. And then you might want to go so far as to create an object in your first scene and attach your navigation script to it. And you might want to make sure that that object will persist across all scenes while making sure that the scene only has one copy of that in the game. That's the use of singletons here, right? So that'll be an exercise for a little bit later using this DontDestroyOnLoad. All right, but here's the one thing you definitely need to have for the Apple Tree game, and this is this notion of player preferences. So also known as saving simple stuff, right? You have some simple data that you want to just kind of keep around. Things like high score or the player's preference on, with regards to the music settings, if it's loud or it's, whatever, or if it's using a particular, if it's at a particular position on the screen, or, the player preferences, background color, dark mode, sort of thing. If they want to using dark mode or light mode, you just have a player preference to remember that. It's not an implementation of that. It's just the data, simple data that would facilitate that. So PlayerPrefs are used to store and access simple data across play sessions, right? It persists, right? The player preferences persist. So in other words, it gets saved to disk, right? It gets saved as part of the project. It gets saved as part of the game. It doesn't create a separate file that you know of. It doesn't really present it that way. It's all like glommed in. So you don't have to do file management or anything. It's all automatic, right? The data will just be saved within the whole Unity architecture and it'll be there and available the next time I'm going to use it. You create sort of a little collection of data. It's to provide a quick and convenient way of serializing limited data. So this term serialization shows up in a variety of things, especially in game programming. For some reason, the act of serialization is kind of, basically saying, okay, I need to take something that currently lives in memory or lives in some abstract data structure, data object that I have, and I want to immortalize it by, somehow streaming it out to disk somewhere, or streaming it outside of the program, sending it somewhere so that it will then be available to come back in again, right? It streams it out so it can pull it back in again. We're not going to use player preferences to do things like serialize the entire game state. If you're really getting into, like a real persistent world where things, moved around and every game object, you need to figure out its state at any particular moment in time, and you can save it exactly where you are, that's going to be something that's sort of considered to be beyond player preferences. And you would likely have developed a much more complex system to do that, or used some other, external asset system to do that, but there are other ways to do that. So I wouldn't recommend using player preferences for that. So to use player preferences, they work by using a string as a key, right? So it's sort of like a dictionary, right? It's this persistent dictionary. You have a string as a key that allows you to refer to some chunk of data that you want to save. That key becomes bound to a particular bit of information that will allow you to save and retrieve it. For example, you might have a key that's high score, the string high score with a space in it, and the capitalization. It's all going to be there. So here's the key, high score. And you want to save the top score as an integer, right? So this player preferences will have a type that they use. But later on, we can retrieve it later using that same high score field, that key. All right. So here's what it looks like in code. All right. To do it, we have certain methods. There's a namespace that's just using Unity Engine. You don't have to say Unity Engine UI. You're using Unity Engine scene management, anything like that, sort of built in, so you don't have to tell it about this namespace, but it's just going to be using it. But there is a class called PlayerPrefs. All right, so we're going to usually be referring to like PlayerPrefs dot something, right? That's the class that we're using. PlayerPrefs dot delete key, has key, get float, set float, and so on. And I'll show you in some code in a second. So common methods that we use, and this key to delete, key to check. Just imagine having your own keys there, right? So we could say, once we've created one, say we had a high score, we could then delete the high score key if we want to remove that from the preferences. We could check to see if a key exists in our preferences. We can also set and get values according to their keys. We do have to tell it, is it a float? Is it an int? Is it a string? And then use the appropriate ones to get them or set them. Setting automatically creates them if they don't already exist. So if you said, set string high score to, or player name to something, it will create it on the fly for you. You don't have to worry about creating it. And then later on, you can say, get string player name, and it'll be there. If you haven't already created it and you called get string, it will allow you can have a default value in your get as well. So for example, if you wanted to get int high score and you put 100 here, it would say, if there is no saved high score already, then just return 100 as the high score, right? So if something doesn't exist already, here's the default value for that preference. Right? So this is what it would actually look like. This is one of these lecture notes that are going to come real handy as a reference here if you want to see it. So, for example, we would say, and this is kind of overly complete. This will actually check the key first if you wanted to. Let's say, okay, during the start of the game, check if there is no key for high score, then it's not entirely necessary, but this is just being explicit so you can kind of see what it would do. So let's say if not, if we don't already have a key called high score, that's what this code is doing, then we should go ahead and create one, PlayerPrefs.setInt high score, and give it some default high score. If we didn't want to do that, if we wanted to just like leave it, another thing we could have done is said high score, and we would do this part to get the high score. We would say high score equals PlayerPrefs.getInt high score, comma, default high score. Right? We could have done away with this part and just use this for that piece as well. All right. And by saving it here, we're talking about saving it into the high score in the game now. This is a little bit, I guess, a little bit confusing to say. This isn't saving the high score to disk as a reference. It's saving it into this new variable here, right? Because it's on disk, but we have to get it into the game. So we're saving it, or deserializing it into our high score variable so we can see it later. And then during loading, we then might want to say, oh, well, let's put it on the screen. So this is a shortcut to putting it into the text of a game object. We're going to say, oh, here's current score over high score. And just, this is just some little print formatting. So we can show, okay, here's the current score, here's the high score in there. And then we might, at the very end of the game, say, well, we want to save it. So the game's about to end. So we would say, okay, if the current score is greater than high score, then we should, using the key, set the integer associated with that key to the high score. or excuse me, to the current score, right? So here's it getting it at the beginning, and here's it saving it as the game ends. Right. So that's all there is as part of this first little bit of the lecture here. So on that note, we should probably just jump into Unity and do something cool with that, right? So imagine we had SnowKid here. What should we do with SnowKid? We're imagining SnowKid, and SnowKid is now dropping. Let's see where we left him off. In SnowKid, he is dropping soldiers, and the player, if I recall, the player is populating a bunch of chests. It's making 3 chests on a stack here. Right? Creates these baskets here, puts them in their array. And then during update, it moves the player left and right. And we had this destroy a basket. And we're not yet keeping track of score, right? We have the number of lives that the player has, just for one reason or another. The enemy behavior is the one that just handles, let's see, it is using invoke to drop things. And the drop rate here, we have update, nothing going on. Now, soldier behavior. This is where important stuff starts to happen. We said, okay, on update, this is if it drops off the bottom of the screen. This one here was when the thing that was dropped collides with the basket. You'll notice we left off this add to score, right? So here's where we'd want to say to add something to the score. So a good place to do that, I think the player should keep track of the player's score. Why do I think that? Well, I always like to imagine, even if I'm designing a one-player game, I always like to think, well, what if I had a multiplayer game? Right. So what things in the game are really important to be part of the player, and the player's score is one of them. So that's why I would prefer to say, all right, the player has the player's score, right? Int my score. Okay. So there's the player's score. Now, to change the player's score, we might want to change that. We might want to set that score to something else. Now, we could go ahead and we could create a function for that. That would be one way of doing it. We could say, well, void, or we could even just thinking ahead. Let's think ahead for a tiny bit. Why not? Public, we want this to be a function that somebody else is going to be able to call. Int, because we're going to be integer-based scores here. And we're going to call it add to, is that right? Yeah, add to score. And okay, we have a function here. So not all code paths return a value. It complained about. Why did it complain? Because I told it, yes, it's going to return an integer. So let's return an integer. And I think that integer should be my score. Right? So if someone's actually interested in the score, they could call add to score and get the score back after they added something to the score. But let's say, well, we want to add something to the score. So we're going to add a certain amount of points to the score. And we would say my score plus equals points. So this is sort of a fancy way to do it, but it's a forward thinking. I like to think forward because I might say, okay, well, certain things you catch might be worth 1 point. Certain things might be worth 5 points. Maybe they're fast dropping apples that they're going to have more, they're going to be worth more points. Or maybe there's going to be poison apples and they're going to be negative points. All right, so we leave that opportunity open here. All right. Or maybe I wanted to just say, oh, okay, I wanted to find the score and I could kind of cheat a little bit and pass it 0 points. So then I would just get the current value back because it would add 0 to my score and return the value. So it's a pretty useful little function here, right? So that's going to be taking care of that. Now, so I've got add to score. That's good. That's good there. And now that I have that, I want to then return back to soldier behavior. And I already did this once over here where we had destroy basket. So I'm going to copy and paste that rather than do all that out. And instead, I'm going to call that function, which was to add something here. And we have a nice, clean sort of interface to the player to add to their score. And if I collided with, I could start getting fancier and fancier in here to say, oh, if I did have multiple players, well, I'd have to have some way of discerning which player it was. But I'm not going to worry about that because I don't want to get too carried away with forward thinking. Anyway, so we're going to add points here. And that's great. Now we have a scoring system, but we're not really doing much with the score. So let's go back to the player. And so now the player is in charge of the player's score. It'd be nice to have some way of putting the score on the screen, of course. So let's see what would be involved in that. We would then say, well, we need some text on the screen probably. So let's put some text on the screen that we can put the score in. So I'm going to create a UI element that is a text element. Let's get it there on our canvas. And we're going to call it score. Right? So let's do a little bit of designing here. So we have score, it's down there. And it's called score. And by default, we'll put 0 in the text. Why not? And let's put it somewhere better on the screen. So we're going to hit the W key for the little move thing. Grab score here. And that's the double click on the canvas. And where is score? Score is all the way down here. So it's off the screen. Oh, let's change this. Oh, it's constant pixel size right now. Oh, I hate when the canvas is constant pixel size. I want to be scale with screen size. And let's see. Let's make it, it's kind of small in the middle there. So we'll make it even smaller. 600 by, or 640. That's not great either. Let's choose our real size, 1920 by, whoops, what happened here? 1080. Nobody's typing over there, are they? Nope. Okay, good. Shout out if you have any questions. Stop me if I'm running like mad. All right. Yeah. So let's say, okay, we've got the canvas now. Let's do that. I'm going to start over. I'm going to say that I'm going to delete out score. I should have said that beforehand. So we have the canvas now set to 1920 1080. Let's add some text. And it's really small there. Maybe 1920 1080 wasn't a great idea. But let's make the font bigger. Let's make the font 36. And now, because of that, I need to make sure that the font box is big enough. That is one thing that's sort of a drag here. All right, that's bigger. That makes more sense. It's good when y'all see me suffer through this, you'll remember it, right? 48, that's getting bigger. 64, all right, even better. See the whole canvas here, click on that, make sure you stretch that one out, move it over here. Let's call it score again. And give it a 0. Or maybe you even say, current. I don't know. Or I could have said just score. Maybe just score sounds better. Like that. Score 0. And let's think ahead. I'm going to be forward thinking again. We're going to say, well, we also need a high score, right? So let's make high score. And we will click on that, move them down. That right there. And we'll type high score there. And I always like putting one on one side, one on the other. I don't know why. So I'll put one there, and line them up. I don't know. Don't get carried away. High score, current score. There they are. High score and current score. Whew. Save our work. Save often. If I had a collaborative project, I would push that up to publish to the project and so on right now and make sure it's going to persist. But let's go back now. We have, we're not doing things in the game manager. The snow kid is the one that has the enemy behavior. Where's our player? There's our player. So every time you add to the score, you also probably want to update the score on the screen, right? That makes sense. So after we add the points, that's the important part. We want to add to that thing. Now, I'm going to blow your minds just a little bit here. So I'm going to do a bit of optimization. So because I'm using Unity Engine .ui, I need to do that to see UI elements there, first off, right? Because I'm going to have text that I'm going to be manipulating. All right. So instead of saying, show me this game object that is on there, I don't necessarily care about all of the game object. I really just want to manipulate the text, right? So I'm going to say, all right, how about we have text called score text and text called high score text. Because the further down the ladder, the further down the hierarchy we can kind of resolve things early on, the more efficient our code is. If we're going up and down hierarchies, like if we start at the player or we start at the canvas every time, we go all the way down to figure out where the text component is, and and do that every time we want to update something, that's very inefficient. So if we know we're going to be manipulating a particular component or even a particular field, potentially, it's good to kind of travel down the tree just the shortcut here and say, well, let's put a public in front of it. There are other ways to get it, but with public text and so on. And now here, we're going to say text dot, and this is a little bit weird, text dot, wait a minute. Nope. I do the right kind of text here. Public text dot. Mm-hmm. I can say text.text. What happened? I've done that. Let's see. I'm having another senior moment here, but wait, we'll get there. All right. Whoops. See, here we did. That's where I was doing that. Text score.text. I specifically said that. Why is Unity? Oh, because I'm an idiot. Well, don't repeat that. I'm not an idiot. I can't refer to this. This is the name of the class. That'd be like saying int equals 4. Dummy. I need to say score text dot text. Right? Yeah, that's okay. That I can do. Equals my score. Right? Do that. Sort of. You'll notice it cannot implicitly convert from int to a string. I could say my score dot to string. That works. Cannot convert for non-delegate type string, my score. Oh, now I would say. Oh, well, I would do this. I would have to say this. There we go. That would work. Sometimes that happens. That's like, so this would give us the string. But I also want to, before that, say score. Right? So this is the most proper way to do it, right? To say score text dot text equals score colon quote, get this is a string here. And then I'm going to add my score as string to the end of that, right? So let's give that a try. I wrote a whole bunch of code and I haven't hit play in a while. And that's going to get me scared now. I've probably broken something. Let's do all that. Let's hit play and see if I'm still good at this game. All right, Snow Kid. All right, and nothing's changing. Why is that? Because I have committed the original sin. You'll notice over here in my player behavior, I have not assigned anything to this field over here, right? So it doesn't know where that text field is. So if I grab score here, it's kind of cool. Unity will do the right thing. Hold on. So I'm going to be careful here. If you're worried about things changing like that, like if I'm trying to drag something to the player and I accidentally click over here, and I'm like, I forgot. Here's this good shortcut. You can lock this so that no matter what I select over here, it's not going to change. That's a pro tip there. So I want to assign score text there. So I'm going to say, okay, here's score. Now, I really don't want the object. I want just the text component within there. But thankfully, Unity will do the right thing. And you'll see this text, it added this text part. So it's saying, okay, you really meant the text component of that object. And it's going to do the same thing for high score. So Unity is very clever that way. So if I had said, oh, okay, give me a transform or something, or give me a position, and I dragged an object in there where it would pull the right component or the right method or the right variable of that component to there. Isn't that nice of it? It's kind of cool. So hit play again. And now, hopefully, we're still not getting it. What did I do wrong now? I know what I did. I bet I know what I did. Is here's soldier behavior, which is going to be calling our add to score. And I didn't save it. That is just, I meant to do that. I just wanted to demonstrate it. It plays much better in class when you're all there, so I can hear you laugh at my jokes and stuff like that. So otherwise, I think I'm just, oh, there we go. Okay, thanks. Thanks. I feel way better now. Thanks for the moral support. But the good news is that our score is changing, right? So we have a score. Yay! And let's see how we can crank that score up real quick. Just get it going. For those of you who weren't here, you want to see this just because it's like so cool. Yeah, there we go. The fountain of soldiers. And there we broke 100. All right, so score is working. Now, obviously, it should have been a new high score that time, but it wasn't. So let's tackle the high score. We have score, we have high score. We're going to use our preferences to deal with that. So let's assume that each player has their high score, or now, for now, we just have one player. So what the heck, we'll keep that in here. Now, during start is where we would want to preload that text field with the right value, because we want that to be seen. Right. So we would say, now we have my score here, but we want to have, and there's going to be a bunch of different ways to do it. Maybe I'll try to do this just different to be crazy. So we have high score as well, int my score and high score. And Is it complaining? No, that's cool. All right. I think in player behavior high score. Did I ever use that somewhere? Maybe it's just suggesting some things. So during our start, and this is normally where we want to like do things. So this is like the start of the scene. We would say high score equals now PlayerPrefs. Notice that it's already there for me. PlayerPrefs dot, and it's going to suggest all sorts of things. Delete all the keys, equals, get float, get int. It's already being smart here. It's saying, you probably meant get int. And the key, now is the important part. I'm going to be basically making up the key right now. And I want the key to be high score. Mind-blowing, right? How original. And I'm going to use the version that has a default value because I want the high score. I'm going to make you earn it, right? So by default, there's a high score of 50 already in there, right? So we have the current high score. Now we got that. We want to print it. So I'm just going to cut and paste because we want the high score text to say high score. Hi, Mark. Can we get that? No? Okay, good. Just make sure. Hi, Mark. I did not. All right. So, all right. Pardon that segue. Okay. So now we've gotten the high score text. We're going to populate the text with high score and put that string there. So we save that. We play the game. We try to play the game. We won't play too far, but the main thing is to see, okay, there's our 50, right? So it get pre-populated there. And if we play again, it's always going to be 50. All right. Not always. For now, it's 50. So we're doing a lot of coding here. The high score, we want the high score to change once the player exceeds the high score. Now, this is potentially interesting, right? So the question would be, I never really thought of this before, but it's a good one. And this is a design decision. Now, we said this add to score. Normally, I would say, okay, well, we add the score. We want to use, if the score, we said, if my score is greater than the current high score, then go ahead and say, high score equals my score. Right? That makes perfect sense. I should do that, right? But what if subsequently the player did something really dumb that we subtracted points away so that caused their points to drop? They would have already earned the high score even though the game didn't end. That's a design decision. That's one to keep if you want to, bonus points work out. We're going to just do the simple case for today. Oops. We're going to do the simple case that's going to assume that the score cannot go back down, right? There are no negative points in this version. We're just going to say, okay, if your current score is greater than the high score, congratulations. Now the high score is equal. You set that to your score, right? And we can do this. Arguably, it's not the most efficient thing to do because in the middle of the game, we're potentially going to be saving this high score out if we do it this way. But again, this is, we're not going to worry too much about efficiency here. we're going to immediately here say PlayerPrefs dot set int high score and give it that value. Is the new value that we just calculated here, and we just save it, right? So the inefficiency there is if I get a, every time I score higher than the high score, it gets written to disk or gets ready to be saved. So there's potentially some inefficiency there. You might want to only have this set int as this scene ends, right? And you guys are just so advanced, I know you're going to want to do it the right way, right? So let's see how we would do it the right way. On, not on disable. Okay. What on disable is, this is the function called when this behavior or this component becomes disabled or inactive. It just so happens that when the game ends, when the scene is unloaded, this happens. So it's actually kind of compelling to put this here so that as long as the game gracefully exits, that's the bad part, right? But if the game gracefully exits, it will set the high score according to whatever the high score was during this round, which should be whatever the high score is. And we avoid this kind of weird potential situation where we're just kind of writing to disk over and over and over again every time the score changes. Do you guys follow what I'm getting at? I should do more. Should do more polls in the other. I was doing tons of polls in my computer graphics class today. So, does that optimization make sense? All right. Also lets me know who's paying attention. All right. All right. Check the poll or else you're not paying attention. You're in trouble. That's right, because it actually, of course, tells me exactly who's reacting and so on. I should totally do that more. And then take a snapshot right after this, right? So no one can add. That's what we do. Screen grab the reactions from now on. Haha. Yeah, I'm getting smart in my old age here. Okay, so now let's see if that worked, right? So we have every time the score changes, we do check, which is valid because we want the player to be rewarded. We want the player knowing, yes, I've got the high score. Yeah, keep going. And I want the score on the screen to change. So that does need to change all the time. But I don't want to write it out to disk all the time because it's really unnecessary and potentially, all of a sudden you're playing your game and you hear because it starts writing to disk and the screen slows down and all that. Don't want to have that happen. So let's not do that. So let's try it. Let's see what happens. Thankfully, it's pretty easy to get the high score in this game, at least the first time. All right. So here we go. 1, 2, 3, 4. I should have to count along, right? No. Just kidding. It escalates really fast. That's the cool thing about this. It's like once it starts going, then suddenly you're just, woohoo. Hopefully I did it right because it does take a little bit of while. A little bit of while. Here we go. Brace yourselves. Get ready. And we're almost there. Boom. And it didn't work. Darn it. Or did it? Well, it only saves it, but the problem that we had is really it just didn't draw it to the screen. Okay, because here's where we drew, like we did it the first time we did this up here, but we didn't change it here. Here's where we draw it to the screen. So that was the one part that was kind of left out because it's not enough to just change the value. Not yet, at least. In the future, we'll show you some cool techniques that will allow you to kind of build in, as we get more into object-oriented programming, which is real fun. It will just, well, you have to plan, but it'll do the right thing depending on how much forethought you have. So now the good news is that the mechanisms were all there. Whoops, I don't want to debug. The mechanisms were all there. So I suspect, ready? There's the high score, 143. Because last time around, it did save it. It just didn't draw it on the screen, right? So now every time I play, it's already saved it to be 143. No. Because now what's happening here is we said if there's no value, set it to 50, right? That's the good thing about this get int here and start, right? So if there's no value, use 50. Otherwise, report the value we actually used, right? Which is that what you're referring to, or? Yeah. So it's automatic, right? This is just if no value existed, but now the value exists, right? So the next question is, and this is the one that, I will know if people paid attention in class or not, because here's the secret Easter egg that you should add. Because everyone's like, oh, how do we reset the high score? And it's tricky. It actually, there's often no simple way to reset the high score because it's persistent. And I don't know if there is a way to actually go into, I bet there's some way to go into the project settings, do this. But what we're going to do for now is just say, well, let's go into the scene. And as part of the player, we're going to say, have some on keyboard input. Well, that's a bolt. No, we don't do that. We could just inside of our update or inside somewhere in here, we would hide in if the character, if M was pressed, we could reset the high score, and we would reset it by saying delete key, right? So the easiest way to say just delete key, or you can have it that there's some kind of special scene. So sometimes what I will recommend is to have an extra scene in your game, right, called the reset screen here, and don't have it reference anything. Don't have it really, it doesn't show up to the player at all, but it's really just used for development. And that one scene, the only thing it actually did is have a game object in it that has a simple script on that says reset the high score. So we'd just do that once. So resetting the high score, usually have some kind of explicit way to do that, so that there's some way. Someone always asks, how do I reset the high score? And that's, you can kind of do that. Or you can make it a preference, kind of thing, right? Let's do this. Let's say, oh yeah, okay, people should do this. In your, let's say save. I don't have main menu in here. Oh, come on. I guess I didn't make this one the main menu. Adventure output you playing see main. All right, this isn't my prototype one. But you can have on your main screen a button that's just like reset player preferences. Just delete the player preferences if you wanted to do that. That's always an option. Well, no, it's like, it's up to you. It's whatever you want to have. Yeah. Well, I mean, you mean in that menu? Yeah, it's a design choice. All the games in the project, but it depends. If you delete all, then it will do all of them, or you can selectively delete them if you want it. Now, remember, if you have high score, it's going to be shared across all of them as well. So you might need adventure high score and shmup high score and apple picker high score, right? If you wanted to have something that was unique to each one of those, you would do that. All right. So let's see. It is now 4. No, it's not 4 yet. It's 3:40 something. What time do we go to? We go to 4:20. We're just going to keep barreling through here again, because, especially because the submissions were good, and we just want to cover game stuff. We're not going to really worry too much about check-ins at this point. We're going to have live check-ins at any point. If you have any questions, the main thing is, get working on your games, right? Get working on these pieces. And you certainly, we'll do a quick poll. How many have, and one of the key things, okay. Here's what we're going to do. We'll do a couple of answers here. Enemy moving, dropping things, catching, scoring, right? So you should be going through. You got moving enemies, dropping things, catching things, scoring things. You really, if you're following along, you're going to be in great shape. If you're not following along, you're just waiting to, it might not be in great shape. So the next projects are all, I'm just going to be like techniques as opposed to, almost exactly, follow along and just do the similar things. So be practicing these things as we preach them. So anyway, back to the apple tree here, or the snow kid dropping stuff. So we have it. We have scoring. We have high score. Congratulations. If you're following along, you're doing well. All right. Now, the other things where it gets interesting, right now, the enemy behavior, for example, we have it, let's see, increasing speed for dropping things. We have, let's see, enemy behavior. Where's update? Yeah, if it hits the edges of the screen, it moves back and forth, but it doesn't randomly change direction, right? So that's a remaining thing. How would you randomly change direction? Right? How do you make random decisions? Well, you use random numbers, right? We talked a little bit about random numbers. So let's see. Let's jump into what was sort of part. Let's see. We did that. We got through here. Yeah. So we've got a high score. We've kind of set things up. We did well with that. All right. Let's now get into the infamous miscellany. Miscellaneous. A group or collection of different items, a mixture. So this is lecture part 2. We're going to talk about a little bit more about singletons, a little bit about structs, a little bit about invoke, a little bit about libraries. All right. So specifically math and random useful things. And maybe even you're going to potentially write your own library functions, which are different than a different case of, we're going to have classes that are libraries as opposed to classes that are components of objects, right? So, retrospective. Again, we're going to go back. All right. Project 1, not going to review too much, but some of the key things, let's skip over part 1 here. But did you use update? Some of you did. Some of you used the update function. You didn't really need to because it was sort of just turn-based. The only thing, things happened in response to the user doing something, the user basically clicking a button, right? Even if it was something dynamic where the volume of sound changed, it always happened in reaction to the user pressing a button or pressing a key or doing something. It really, you know, you didn't need to use update. There was nothing really that dynamic. All right. So we didn't really do what is called polling. We weren't checking things continuously over and over and over again. A lot of the time in update, when we're doing input, we do this through polling. Like we say, oh, is the mouse position here? Is the position of this other object here? Like when we're doing the checks to see, has the enemy walked off the sides of the screen or fallen off the bottom of the screen? That's kind of polling, where we're just kind of continuously checking, right? That's the sort of thing that happens in update. Now, again, warning when this used to be, depending on what part of the thing here. So it's kaboom with apples, right? Remind you, in case you didn't remember that. So remember, you are developing progressively. The game should play progressively. It doesn't start out as insta-kill. It doesn't start immediately as hard as possible. So in games in general, you want that to be the case. Hopefully there are things you learn as you play. You know, like I've gotten pretty good at, you know, just following around in that one. You know, it's the challenge becomes designing the game so that, you know, you can't entirely just memorize things. We use scenes normally as level and structure. We like to have a start screen to let the player choose the level. You should always be aware of things becoming too complex. And we're mentioning that because we are potentially bundling our games into one project. And the progression we're going to have typically is, you know, the complexity of the programs themselves, of the projects themselves, but you can also imagine that being used. All right. Let's see where we're going here. So a few more C# programming practices, some really useful Unity scripting features, and some patterns. I mentioned this about singletons before. Singleton, how you can potentially say, okay, I only want one of these things. I only want one of these mono behavior objects, right? I only want one player, or I only want one background music audio thing, right? So it's very useful for that. So the singleton pattern is a way of checking when the object comes into existence to make sure it is the only one, right? So basically, it's like playing a game of musical chairs, right? Where there's only one chair. And every time the scene starts, you might throw another person into the game. They'd wander around the musical chairs, but then ultimately there's only one seat for them to be in. So that's how we sort of can enforce this idea of only one thing existing at a time. Now, we've seen public, we've seen private, we've seen void, but I don't think we've seen static before here. Static is relatively new. So what a static thing is it's basically something that, again, it persists. There's only one of them, and they persist across all instances of this class. So if I declared something to be static, it would be shared across all of the instances of that class. So for example, if all those soldiers dropped and I had static, you know, public static is game playing, they would all share that one same variable. So with this structure here, if I said in any particular class, I said private static singleton instance or private static background music instance, that would be declaring a reference here that was shared across all members of that, or all instances of that class. And they can all refer to that, even though it's private, because it's across all of them. And because of that, we can have what's called a getter function here, and we can get that instance. We can look at it. Basically, it's like that game of musical chairs, right? Everybody can see that empty chair, but only one person can sit in the chair. And we have to be able to say, okay, we don't try to do the gag where everybody tries to sit in the chair. No, we respect the fact that whoever gets in the chair first, everybody else says, oh, there's already somebody in the chair. I have to jump out the window. Sort of what happens in this case. All right. So this structure here, this public static singleton instance, is a way of getting this private value and seeing does it exist. All right. Now here, this is a new feature as well, this thing called this get. We haven't seen that before. And this is also a practice that's more widely used in object-oriented programming to make sure if you want to hide a particular value or you want the interface to a particular element of an object to be done through appropriate means, or maybe you have something it's a more complex setup or a more complex operation on it. You want to get it through this kind of special mechanism, right? We use this thing called a getter. We can declare that so that if you said instance, you refer to that instance at all, you'd refer to it through there. All right. So then within here, you remember we had start. We have the start function, but we also have this function I haven't told you about yet called awake. And awake happens even before start happens. Right? Awake is kind of a bonus to like the very, very first thing that everything does is they wake up. And that's like the earliest you can look at a particular object, right? So at this point, no other start things have been called, no updates have been called, and so on and so on, right? Awake is coming up. And this part here is the musical chairs, where it says, if this value underscore instance does not equal null, which means somebody's already sitting in this chair, right? If it's not null, null means empty. So if someone's already sitting in the chair and the person sitting in the chair or the object sitting in the chair is not me, it has to check because it's kind of destroyer of worlds here. It is Zool, I guess. Wait, who's the destroyer of worlds? I forget. So it says, okay, if the chair is not empty and the person sitting in the chair is not me, then I have to do the responsible thing and bow out. Say, okay, destroy this game object. Destroy me. I should not exist because the chair is not empty and I am not in the chair. So that's why I would say, okay, destroy the game object. Otherwise, you're happy to say, okay, the chair is empty and it's not me, or the chair is empty and I need to set myself up here. So you then say, okay, get in the chair, set the instance to the current object, and don't destroy me so that I can persist. This part here, the don't destroy unload, that's the more unique to Unity part. But everything else is kind of part of this common practice. You'll see even in other projects, other computer science disciplines and things, you may need this sort of structure where you want to have only one of a certain object, right? So this is what's going on here. So you can refer back to this slide if you've heard of Singletons and how they're basically this kind of very elitist musical chairs kind of thing going on. Structures and versus classes. How many of you have heard of structs? I don't know if maybe I shouldn't be. How many of you are like done any old school C programming or things? So some of you have heard of structs. All right. So in case you are working with other programming languages, you may have heard of structs, which are similar to classes, but not quite. Right? Structs are actually, they existed before classes. They're sort of the little sister of classes. I don't expect you to use them in the projects of this class necessarily, but it's something to be aware of just in case you're looking through any code and you see it. That similar to classes, they are sort of like small objects that contain a whole bunch of data. This is actually a struct here. And look, it has variables and then some of them are public and it has methods and so on and so on. They're different in that you quickly spin them up on a stack. You can use them, you can create them on the fly. There's no such thing necessarily as a struct.cs file, right? Classes are created sort of at that class level. They have a file. They are a larger, more proper citizen, where structs are just sort of a much more simpler structure within the language. And they're meant to be used kind of much more dynamically and you create them on the stack as opposed to the heap. So they're just like more sort of a temporary variable unless you declare them globally anyway. So there's something to be aware of. So if you do see structs in any code you're looking at or a project, you say, well, okay, they're kind of like a class, but they're more kind of transient in nature. They're not meant to really be, very, very complex, but they are very useful when you want to create, like, say, some group of things or an array of, small items that have certain things in common and so on. So this is just a random, put that in here. So structs versus classes. This is a good one. This is a really good one to have. Navigating scenes and objects in the hierarchy. Now, before we did that bit where in Unity, right, this is already hopefully now your favorite thing now, where we did this in the player behavior where we referred directly to the text of this object here, right, without going through the whole game object. But for example, over here in the soldier behavior, this was lazy on my part, and now I'm going to make up for it. Okay, game object.find player, get component, player behavior, blah, blah, blah. Going down that whole list, that is inefficient and lazy on my part because it's basically, I have not thought of things ahead of time, so I wanted to find them. The one cool thing about it is that I didn't actually do it through a public game object up here. So that was good on me, right? I could have had public game object player and then had to have set it up in the Unity editor interface. So good on me that I, did this the programming way, but bad on me that I do it every time I need that, right? Which is particularly bad because, this might happen all the time here, when this detection here, right? That's not a great thing to do over and over and over again. So ways we can avoid that is that there are lots of different ways to get and navigate the hierarchy, right? In that case, we were using that game object find player. So instead of, this is the first thing, instead of using the public game object, use game object.find, right? That's one nice thing in that you don't necessarily have to set it up in the Unity editor, but it's a little less efficient because it does involve navigating the hierarchy a bit. Then from there, we have things like GameObject.getComponent to find a specific type within there. We have getComponents if we want to find multiple components as an array within the type, and so on and so on. Right? We can also do this one other cool thing to say try getComponent. So imagine you had an audio, you think there's an object, or many of your objects in your game have audio sources on them to, when the, you hit a bullet hits the player, a bullet hits your game objects, maybe most of them have, unique objects or unique audio sources associated with them. And you want to play the sound that's on them. So you might use this try get component to see, does it really have one before playing it? So it's kind of a neat feature, but you're probably not going to use that. Now, so what's the efficient way to do this? So now we know about these things that we can use game object find and we can use get their components and so on. So I'm going to make up for that sin over here and show you what I would recommend doing, where what I want to look at here is I have this player behavior component. That's really the thing I'm interested in. So what I should do up here is I should really have a reference. And just like I could have a reference to text or a game object, I know about this player behavior class. I created that class. I can refer to it like a class, like any other component. And so we'll call it PB. Right? So this is a reference to a player behavior. Now, before I use that, I do have to make sure that I set it up. So I'm going to set it to private as well. So just to be explicit here, by default, it would be private, but I'm going to say it's there. And now during start, I'll do this. I will say PB equals that. So now I'm saying, okay, PB is going to be set to the reference, the player behavior component that's on the player object that's in the game. All right, so I do this just once for this particular instance of this class. So the soldier will know about that. So now I'm free to come down here, remove all of this hierarchy, and just say PB.DestroyBasket. Down here, I could say PB add to score. Right? Life is much simpler that way, and it's more efficient. Right? As long as I remember that, yeah, what PB is a reference directly to that player behavior component, the player behavior class, the instance of that class on the player object. Right? So that's this is good practice. Right? Set it up once, use the start to set up that sort of thing. Okay. Depending on how good of a mood I'm in, I take points off or not. Oh no, well, we'll see. I'm going to urge you. Certainly, it'll always, you won't lose points for doing things efficiently as long as they're not, opaque. Right? By opaque, I mean difficult to understand, difficult to follow. Right? We're going to try to keep ourselves from writing opaque code at this point, but you want to write reasonably efficient code. So, all right, these things are actually all related. And by the time we're done, maybe it will be understood why. All right. So I'm going to introduce libraries. And we've used libraries a bunch of times. Classes that are libraries. Libraries have namespaces and so on, like the player preferences. That's sort of a library. The UI, those are sorts of libraries. Most of those are built around the monobehaviors. They're built as components inside Unity. But PlayerPrefs, for instance, that wasn't based on a monobehavior. That was just a serialization library. Maybe you've used mathf, the floating point library, right? So if we wanted to do something like call an absolute value of a floating point number, we would use the math library. We'd say mathf.absfoo, and that would give us the absolute value of this floating point number, foo. And to use it, we would just go ahead and do that. And there are other things in the math library as well, like mathf_clamp, which would clamp this value or give us a clamped version of this between some lower bound and some upper bound. So if you wanted to clamp something, its position on the screen, you didn't want to go off one side or the other, you could say mathf_clamp value x, comma, -4, 4, and it would clamp that, right? But we'd be using this math library to do it. There's also a random library. There's a library we can call to get random values between numbers or just get a random number. You can create, let's see, you can create your own libraries. And this is the case here. Oh, I thought I had a slide for this. I'll have to go back and add a slide for this at some point, or if anyone has any questions on this one. So here's how we would do that. Imagine we wanted to keep track of this. Is sort of another way of having something that everybody can refer to and also potentially make things easier to follow. So for example, if in my game here, I have player and player behavior. I'll watch this. Let's see if this will work. Remember we had destroy basket. Now, yeah, I probably can't do that. So if I want something to be static or shared across and accessible to everyone, it can't be related to a particular instance of a class. So here, if I want to destroy a basket, I would have to make sure that there's only one life count. There's only one basket array. So let's go through this, and maybe if it works. So let's say also, okay, here's my player. Now, arguably, could we do this? We can't declare the whole thing to be static. Some of our libraries are static because there's only one math library, right? Now here, anything that's a mono behavior, it's tricky to make it static. So we're not going to do that. But certain things in it, we're going to say that, all right, there's only one. Let's assume that there's only one of this type of player, so that they're all going to share life count, and they're all going to share their score, and they're all going to share. This might be possible. Let's see. They're all going to share their basket array, right? So these are static. These are just references, so I can go ahead and do that. So now I'm okay with that, this down here. And let's go one step further and see, can I do this? Can I say static add to score? All right, nothing complains, so that's good. Public static, static public. Let's try this. Be consistent. All right. Now, the nice thing about this, we've said that these things are static, that only one of them can exist. No matter how many players we have in the scene, there's only one version of them. There's only one version of these particular variables because I declared them to be static. So if I were to come over to the soldier over here, you'll notice it got a little weird now. It says, all right, cannot be accessed with an instance reference. Qualify it with the type name instead. So what does that mean? It says, well, you no longer need to refer to it like that. You can just say player behavior, destroy a basket. And we can just say player behavior, add to score. Because there's never going to be multiple versions of add to score. There's never going to be multiple versions of destroy a basket. Right? This is a little bit of an advance. If you're scratching your head a little bit confused, it's natural. This is a little bit of a more advanced topic, and you can certainly go ahead and it's valid to do it the other way around. Right, but this notion of statics and the notion of libraries and kind of sharing things, I like to include that as it's kind of another way versus, even the preferences and things, sharing stuff across objects. So let me make sure this works after I did all that, because that would be a cruel trick if I did all that and it didn't work and I didn't at least try it to prove that it worked. I'm pretty sure it's going to work. No. What happened here? Let's see. Object reference not set to an instance of an object. High score text dot text. Did I clobber that? Yeah. Player, let's get rid of that. Was that in soldier? Where was that? Player behavior, static public, high score text. Oh. This is slightly. This is one situation. Now, because I was trying to set it through this is potentially problematic. So now I have to do a little bit more penance, a little more, more work to back this up. Because now the problem is that these things here, these canvas elements, they don't exist as something that's static across everything. They are instances, they really don't exist until everything starts running. So I have to make sure that they exist, or that I get them in such a way that they are that they're going to be all right. Now, let's see. It was high score. Since there are multiple references, I've made myself a difficult bed to lie in here. So I could do things like have multiple references and then say, during start, what I'm going to do is I'm going to say, all right, here's kind of a one clever-ish way to get around this. This static version I'm going to call underscore. There's the other version. And you'll notice here, that's where I need to be referencing the static version of those. Right? Because I wanted this to be a static function. I need to create a static version. So I need to do some housekeeping to make sure before add to score is called, here in start, I could say underscore score text equals score text, right? That's legal. And yeah, I have to apologize for this being more of a little bit more advanced than, but if you follow this up, you get bonus points for you, right? So now I had to do this little sidetrack here to say, all right, I'm going to allow this particular instance to set that up for us here. So let's get our score text here. Oh, no, let's get score, put that there, high score, put that there. And hopefully we should be back in business. All right. So that one was a tricky one. That's I wouldn't blame you if you stay away from using static things, and instead, if you want to be explicit, especially in this next game, I shouldn't say the first game, to just go ahead and refer to those and avoid using statics. But like I said, the nice thing about static is if you know that there's only one instance of an object, or you're creating a library that you only want to have, like we don't have multiple math library, or, the multiple instances of the same math library, we would use that as a static. So this is technically probably a little bit more advanced. You're probably all like freaking out. Like, don't worry, I'm not going to take off points for not doing this. So if this is a good thing, if I would totally expect people to have questions or be like freaked out by this. So, but okay. So if you did, yeah, it's tricky, especially as you start going across scenes. Even then you can see there's some other bits of that too, because then you have to be static, but you'd also have to make sure things still that they still, depending on where they are. Yeah. It can be tricky. So let's not confuse everybody. Yeah. So anyway, all right. So that's this advanced topic, and it is almost 4:20 on a Friday. So let's see. Let's wrap things up here. So, yeah, conceptually, just so you know, someone went through all that trouble for you when it comes to math libraries, random libraries, and so on. So if you wanted to set up a simple library that didn't rely on instantiation and didn't rely on, mono behaviors, and you just wanted to have a library that compared two numbers and did the right thing or something like that, or printed out a value, simple things that you want to just have a standard, like a little utility library or something, you could use a static class or static library to do that sort of thing. It's handy for that. We've already talked about invoke, but I wanted to mention a couple of things that we didn't quite cover with invoke. We did invoke function with a delay, or invoke function repeating with a delay and an interval. There's also cancel invoke, which will cancel a particular function. So imagine you had it dropping and you didn't want it to drop any more apples for some reason, or or you wanted to pause it, or you wanted to change something, or you wanted to change the interval. Maybe you could actually be calling invoke repeating and then call cancel invoke that function, and then invoke repeating with that function again if you wanted, right? So there are ways to cancel invocations once they're running, especially this invoke repeating, right? And if you call cancel invoke without telling it about any function, it will cancel all pending function calls that belong to this particular class, right? So that kind of completes the invoke stack of things. And here you can refer back to this if you didn't quite follow along in the last lecture in terms of how we wanted to invoke functions recursively at intervals, where we had that, the drop rate continuously increasing, or in this case, look at that. This is change direction randomly. So maybe this is how you might want to change the enemy's movement randomly, right? Invoke it at some random interval, and then invoke it again at some random interval, and change that direction variable explicitly in there. So there's a little hint at the last bit of that lecture bit. Whew. All right, I got to catch my breath now. Any questions on all that stuff? I will put these. I'll make sure these lecture notes are up right after I finish this, so that they'll be more available or more timely than the last ones. Well, I had to do that because I wanted to be able to call those functions without referencing a particular instance, right? So that was the one. The simple case was, okay, because I wanted to be able to do this, player behavior.add score, right? So in order to do that, this to refer to it by the name of the class, this function here, or this method, has to be static, right? Otherwise, I have to get a reference to a particular instance to call the instance method of that class, right? So that decision right there pushed me to change this to static, but then everything, all these references in here needed to be static as well, which is why I needed this high score and this score text to be static, right? Everything in here also needs to be static. I can't have instance variables inside of a static function. Whew. All right. Anyone got good weekend plans? What's anything fun, relaxing? Just gonna work on your projects. You just dive right in and. Fair enough. Animations. What sort of animations? What are you doing? Can I ask? You don't have to. Oh, this. Very nice. Using that. That's all Maya, right? That's with Professor Rosenka. Is that right? Things translate pretty well these days. Industry-wise, it's never going to hurt you to say, yeah, I can do all this stuff in Maya, because everyone will say, oh, you can probably pick up Blender. Then, but industry, if you say, oh, I only knew Blender, then it might say, well, you need someone who knows Maya. So, well, that's changing. They use it for a lot of projects that aren't like mission critical or like high profile. You'd be surprised. I mean, I've certainly heard, people have mentioned, even at some of the bigger studios, like for personal projects or little utilities or, you know, because there's lots of opportunities for things being kind of cross compatible. I know I've been kicking Blender around for a lot longer than I've kicked around Maya, so I tend to be a Blender person, but I wouldn't say that I'm in a position to instruct on it. So I'm a Blender hacker, more of that. Fun. Yes, prosumer. That's what I like to refer to myself as. It's like one level above hobbyist, but not, you know, I'm not going to create a Blender movie for Hollywood just yet. So, all right. That you've got plenty of ammunition for fun stuff. All right. Yeah, depending on how things are going. Do we have, actually, this is a good question for me for later. How many of you, poll, how many of you working with Maya? Later on, we will have the opportunity. I do a gentle introduction to 3D in Unity, and kind of 2.5D. You know, if you're familiar with 2.5D games, so we can kind of import certain like 3D assets and things like that, but within a you know, sort of 2D game structure. So there are a couple of things I can, maybe I'll just post them as other references for people who want to import Maya assets into Unity. I won't cover that in class. That doesn't make sense too. If only a couple of people have. I'll also post some things. If you're Blender fans and you want to say, okay, how do I get Blender stuff into Unity? That can be cool. You know. All right. Have a great weekend. We're done. Take care. Okay. Well, we'll definitely have power-ups in different capacities. Both the final, I'm going to expect to see power-ups in both the shoot 'em up, you know, the top-down game as well as the platformer. Can you do? You can certainly, if you wanted to do a power-up sort of thing in the Apple Tree game. That is certainly valid as well. I mean, what a power-up is, in my definition of a power-up, you could have something that's like extra lives and things like that, just added baskets. You know, you get certain score, or the enemy drops certain types of special items that, you know, that then can give you certain skills and so on. That's not a requirement, but if you wanted to do that as part of the Apple Picker, you certainly can do that. The version that I did, that was my Scarecrow game, definitely had that. But the other two games will have that. I mean, I'm not sure if you're trying to refer to some kind of specific, something more specific by power up than that. More like collectible items or interactables. Yeah, we'll definitely cover a lot of that stuff. Okay. All right. Take care. Go get something to eat. Enjoy. Try to have you know, be as sociable as you can, but don't. All right. Take care. Have a good weekend.